So first, let's try to understand the problem. So for this problem, we're gonna use a double linked list, and we're gonna use a cache to solve it. So here the cache, I mean a dictionary. So for example, if we have a 3 node like 1, 2, and 3, so basically we're gonna have two operations. So one is the one is the get operation, and another is the put operation. So for example, if we were to get a node, which is this node 2, so after we get this node, so this node gonna become the least recently used. So this gonna be the least recently used. So after that, so this node 2 gonna be here at the left side. So this gonna be 1, and this gonna be 3. Yeah, because this is the least recently used. Because if I have another node, if the capacity is 3, so I need to pop out this node 2. So this is the basic idea. So I'm gonna prepare a head and a tail, and here gonna be a tail. Because this is only works for get operation. If it is for the put operation, basically I would to put a node. This means I would to put a node at the end of the node 3 before the node tail. If I use a singly linked list, it's going to be another O(n) time. So currently I need to do the put operation in O(1) time. This means I need a doubly linked list. Yeah. So if we understand from here, everything should be okay. So for example, if we are going to put a node 4 between this node 3 and the tail node, so definitely we need to connect them. Yeah. But if it exceeds the capacity, we need to remove this node 2 out of the doubly linked list. So here, gonna have 2 connections, and here we need to remove this node 2, and here gonna be the head. Yeah. So this is all the operations about how can we solve the problem. Now let's first try to code it up from here. I'm going to prepare two other method, which is going to be a helper method. It's going to help us to write the code very clean and concise, and to avoid so many mistakes. So definitely this problem is it's not the most difficult problem, but it's one of the most problems that we definitely we would make a lot of mistakes, and we're going to consume a lot of time to debug. So it's easy for us to prepare a helper method like the remove with a node, and another method gonna be insert with a node. Yeah, so this means whenever we do the get or put operation, we need to use the remove and insert method very often. Yeah, now let's just start the preparation. We're gonna need a doubly linked list, so I'm gonna prepare a class. It's gonna be a list node, and the definition gonna be self with k and value. This is what we need. And because for the dictionary for our cache, we also gonna prepare the k value pairs. K is this k, but the value gonna be this list node. So here self dot k and self dot value gonna be equal to this k and value. Here I want to prepare some value from the beginning, so I'm gonna prepare k and value equal to 0. Now I want to prepare the variables inside of the LRU cache init. So I'm gonna prepare a cache. It's going to be an empty dictionary, and the self.capacity is going to be equal to the capacity. And I also need to prepare the doubly linked list. It's going to be the self.head going to equal to self.tail going to equal to this list node. Now I want to connect the head and the tail together. So this means the self.head dot next and self.tail dot previous. The head dot next gonna equal to the tail, and tail dot previous gonna equal to the self dot head. Yeah. So this is the basic definition for the problem. Now we're gonna write the get and put method. Yeah. So according to the question, this get we're gonna return the value of the k if the k exists. Otherwise, we're gonna return a -1. So let's just check if the k exists. So if k inside the I'm going to use a cache. So if it is inside the cache, it means it is exists. So I'm going to prepare this node. It's going to be the self.cache with this k. And first of all, I know it is exist, but I want to do all the operations in one time. This is really important. So if it is in one time and this node has just visited, so this means I need to remove it. So I'm gonna remove this node, and then I'm gonna insert this node. So the idea is that if we have node like 1, 2, and 3, now we are going to get this node 2. If we get this node 2, we're gonna remove it first, and then we're gonna insert it here. Yeah, we're gonna remove it, find it. We're gonna use this k inside of the cache. We're gonna find it, and then we're gonna remove it. But we're gonna insert it at the head, because here is a dummy node. It's gonna be the head, and here after that it's gonna be the tail. And here in between, we just to remove this node. Yeah. So this is the basic idea. And now let's just write this remove and insert. So the remove is inserted just here. Yeah. So according to this kind of operation, basically it is a doubly linked list operation. So while we do the remove, we need to find the previous and the next node of the current node. It's going to be the node dot previous and the node dot next. Now we just need to do some connections. So the previous dot next and the next dot previous. So the previous dot next is going to be the next, and next dot previous is going to be the previous. Yeah, it's going to be the prev. So this is just the operation. So while we remove this node in between, and we're going to connect them together. So this means this node 1 gonna connect this node 3. So this is the previous dot next gonna be the next, and the next dot previous gonna be this previous. Yeah, so this is just the remove operation. Now let's just go to the insert operation. Similarly, for the insert, we need to find the prev and next. So, but here the prev and next, I think I did something wrong about the explanation. It should not insert at the head. It should insert just one position before the tail. If we want to remove one node, we can remove anywhere. Yeah, but if we want to insert, this is gonna be a new node. This node gonna be the most recently used, so we're gonna put it here. If it is the least, it's gonna be at the head, but here we're gonna put it at the tail, so we're gonna put it in this place. So this is gonna be the insert operation. We're gonna put it exactly here, just one position before the tail. So this means we need to find the tail first. So self.tail, and one position before it is gonna be the self.tail.prev, and the next gonna be the self.tail. So basically we need to do two operations. First of all, this is our current node, this is a tail, and this is a previous. Yeah. First of all, this previous and the tail gonna connect to this node. And secondly, this node gonna connect to the previous and the tail. Now it's gonna become a doubly linked list. So the prev dot next gonna equal to next dot prev gonna equal to this node, and the node dot gonna connect to this node. And secondly, this node gonna have a previous and gonna have a next. it's gonna connect to the previous and next. This node dot previous and this node dot next gonna port it to prev and next. Yeah, so this is the remove and insert operation. So if we finish this operation, we can start the put. Yeah. So let me just check the insert if it is okay. So we're gonna update the value of the k if the k exists. Otherwise, we're gonna add the k value pair to the cache. Yeah, if it exceeds the capacity, we're gonna evict the least recently used. Yeah. So how to evict? If it exceeds the capacity, for example, we have 1, 2, 3, and the capacity is 2. We just need to evict the least recently used. So this 3 gonna be the most recently used. This is according to our design, and this 1 gonna be the least recently used. We just need to remove this 1 if it exceeds the capacity. So there's a lot of details. If we if we ignore or forget some about the details, we're gonna make mistakes. So we have to read the questions carefully. Although it is a very short description, but we need to check that carefully, especially for this put method. Yeah. Now let's just write this put. First of all, we're gonna check if this k is inside the self.cache. So if it is inside, basically we want to do a remove operation first, and we want to find this node. It's gonna be the self.cache with the k. And then, no matter if it is inside or not, we're gonna find this node. It's gonna be our new node. It's gonna be the list node with a k value pair. Now, we want to do a self.cache first, and the cache gonna be this k, and the value gonna be the node. And after that, we're gonna do the insert operation with this node. Yeah. So the idea is that we are having this node like 1 and 2, and the capacity is 3. Now we want to insert a node 3. So what are we gonna do? So this 3 is not inside the cache because our cache with case of 1 and 2, we don't have the k, so it is not inside. But what are we gonna do? We're gonna prepare a new list node 3, and we're gonna put it inside of the cache, and we're gonna insert it. So after insertion, this is gonna be node 1, 2, and this is gonna be node 3. But after we insert this 3, this means the length of the cache is gonna be 3, but our capacity currently, for this example, is gonna be 2. It exceeds the capacity. It means we need to pop out this node 1. Now let's start to pop out that node 1. So we're gonna have a check if if the length of the self.cache is more than the length of the more than the capacity. So this means we need to pop it out. So we're gonna find the LRU node first. So this node gonna be the self.head.next. So this is exactly what I mean, this node 1, because before it we need a pointer which is a head, and after this node 3 we have another pointer which is gonna be a tail. Yeah. First of all, we're gonna find this node, and then we're gonna remove this node. So it's gonna be the LRU node, and after that we're gonna delete it from the cache. So the self.cache with this node.k, because our k is the node.k, and this is gonna be the k. According to this k, we can find it inside the dictionary, and we can delete it. I think that is all. I think that is all the information we need. Yeah. So this case have a lot of meanings. Yeah. So if this k is inside, basically we don't need to do it. Otherwise, if it is inside, we're gonna insert it. Yeah, so if this key is inside, but in our operation, actually we did a remove first. After that, we did an insert. It means all the keys are going to be unique. Yeah, I think that's all for it. But before testing it, I would like to have a double check. Normally, I never solve this problem in one pass. I mean, I have to make a lot of mistakes before solving the problem. So let me just have a check. So this is a cache and capacity, head and tail, and connected, and this is the get, and here gonna be the put operation. Yeah. Now I think I have to run it to have a check. Yeah. So here is a typo, and let me run it again. And here is a mistake. So this means the get operation for this node 3 and 4 it is wrong. Let me have a check. I remove it first and then I insert it, and I forgot to have a return because there are two different cases. So if we're going to return the value of the k if the k exists. Now the k exists, we're going to return the value of the k. It's going to be the node.k. Otherwise, we're going to return a -1. So this is exactly as I said. I never solve this problem by one pass. I have to make a lot of mistakes before solving it, even though I solved it many times. But yeah, I don't know why. While I come across this problem, definitely I made a lot of mistakes. Now this is another one. So this get gonna be 2. I put a value, and if I get this 2, I think I need to return the, let me check. Return the value of the k, but not the k. That is why, I think. So let me just return the value instead of the k, because we are asked to return the value. Because here said we're going to return the value of the k if the k exists, otherwise we're going to return a -1. Now let me just run it and submit it again to check. Yeah, now as you can see, it works. Yep. So I think basically, if we already know we're going to use a doubly linked list and we're going to use a cache, it should not be so difficult. The difficult part is about the details. If we didn't read the problem carefully, definitely we're going to make the mistakes. I think that's all for it. It is a lot of coding, but I've already reduced the code to less than 40 lines of code. It should be okay if we write it from the beginning. I think it should be okay. We can finish such kind of code, because definitely the definition is not so difficult and the get method is not so difficult. Only the difficult part may be about the put. So the put operation, actually we did a check. So if the k is inside the cache, so we're going to remove it first, and then we're going to insert this node. At the same time, we need to update the cache. And if the length of the cache exceeds the capacity, we're going to find which node needed to remove, and then we're going to remove it, and we're going to update the cache. So I think that's all for it. Thank you for watching. See you next time.